Hello, my name is Hanif from the International Islamic University Malaysia, and today I will be sharing a One Health implementation case from Malaysia, focusing on how environmental microbes to connect to antimicrobial resistance and ultimately impact human health. This work brings together environmental surveillance, molecular diagnostic, and community engagement through the CO Hun Fellowship. Okay, so this is my presentation outline. So we look into the introduction and to my original works that coming from environmental surveillance, leptospirosis project, melioidosis project, from culture to genomic, in the case of generation sequencing, fungal MR, the silent threats, and the innovation in my lab, and where we bring the outcome from the lab to the community. To begin, let me briefly explain why this topic matters globally. So, globally, about 75% of emerging infectious diseases are zoonotics, and they are originated from animals and environmental sources. These pathogens emerge and persist within the environment reservoirs, such as soil, water, and ecosystem. So if we only focus on hospitals, we are already looking too late. Infectious diseases don't begin in hospitals, but they begin in the environment. At the same time, antimicrobial resistance is accelerating. This challenge with projection of up to 10 million deaths annually by 2050. So the key question here, how do these environmental processes translate into human disease? So let's look at this pathway in my next slide. As we are moving along this pathway, everything begins in the environment where microbes exist naturally as a reservoirs. From there, they interact with animals, which acts as transition pathway. Eventually, they reach humans, where we see as a disease outcome. And importantly, these outcomes are shaped by our system, including diagnostics, healthcare infrastructures, and policy responses. Every stage is interconnected. So in my work, I focus on understanding this pathway, starting from the very beginning, from the environment. So this work was conducted through my affiliation with the COUN as a COUN fellow that embedded within Malaysia's public health system. So my focus spans three main areas throughout that fellowship: environmental surveillance, molecular diagnostics, and finally community engagement. Together, these form a complete One Health pipeline. So from detection to impact. So that's what happening as well in my Institute of Planetary Survival for Sustainable Wellbeing. We're focusing on the food security, climate crisis, health empowerment, and also any advocacy work to and research work to conserve and sustain the biodiversity. Let me start with environmental component in my next slide. So in this project, we conducted environmental surveillance for leptospirosis. We collected water, soil, and rodent samples from high-risk environments. The goal was actually to perform early detection of zoonotic pathogens before they can reach human population. So in the laboratory, we confirm the presence of Leptospira using microscopy and culture. This allows us to link environmental samples to actual pathogens, but traditional method alone are not always sufficient. The transition from laboratory to molecular is very important, and this become more evident in my next example of the project. So in melioidosis project, we targeted Bocodura pseudomale using a culture, PCR, and sequencing technique as we expected to detect this pathogen. However, instead of identify the targeted species with Bucodura pseudomale. We identify other Bucodura species. In this case, we found that is a Bucodura territory and Bucodura stagnalis. That's highlighting the complexity of environmental microbiology. This shows that without molecular tool, I think we risk the misidentification. We risk misidentifying the true microbial landscape. The environment is far more complex than our assumption in the beginning. So to address this, we applied the next generation sequencing tools using Oxford Nanopore technology, and this allows real-time portable sequencing of microbial DNA, and it also enables rapid pathogen identification and environmental genomic surveillance. Simply put, genomics allow us to see what culture cannot at the first place. So this is showing that the shift from the culture that we need to implement here in order to discover what the culture cannot, and this is helping us in terms of a comprehensive detection or looking into hidden or unculturable variants, and also looking into the benefit of the speed in terms of real-time portable analysis. Okay, beyond bacterial pathogen, fungal infection, an emerging concern as well. Fungal antimicrobial resistance is still under-recognized, but is rapidly increasing. For example, in my laboratory, we're looking into Candida auris. So Candida auris is a multi-drug resistant pathogen associated with the healthcare outbreaks. And we see that its emergence has been linked to climate change as a selective pressure. This highlights an important gap. We need better diagnostic for fungal pathogens. So this is an illustration show how environmental and climate factors can drive the emergence and spread of fungal pathogens like Candida auris. Again, this is this concept or this story linking Candida auris to the environment, reinforcing the One Health connection between the environment and disease. So if you look at the figures here, the hypothesis proposes that climate change could have led the thermal adaptation of Candida auris, transforming it into a pathogenic species. This adaptation, combined with the ability of C. auris to survive and spread in warmer conditions, perhaps by birds across the globe and to rural areas where people and birds are in a constant contact. So to address the diagnostic gaps, our work in the lab explore the biomarker-based detection platform. We are developing a nucleic acid biosensor for identifying Candida species, including specific detection of Candida auris. Using a multi-component nucleic acid enzyme or enzyme-based approaches, we can achieve a duplex detection within a single system, where the goal is simple: to make diagnostics faster, scalable, and more accessible. So, but One Health does not stop at the laboratory. We also translated this work into community engagement through the activity like hand washing, clean hands, healthy life program is very exciting to involve in this activity and to organize one. And we do have annual programs involving school children, and this is one of the example. And this involves educating school children and training the educators as well, the teachers, the laboratory assistant in the school on hygiene and One Health concepts. Because science, we believe here, must ultimately translate into behavioral change. So from this work, there are several key takeaways. Surveillance must begin in the environment. We believe that molecular tools reveal hidden microbial risks. Diagnostics are essential for AMR control, Fungal AMR is an emerging global threat, and importantly, education ensures long-term impact. Together, these form an integrated One Health approach. Moving forward, the focus is on expanding genomic surveillance, strengthening multiplex diagnostic, scaling community education, and building regional collaboration because these challenges cannot be addressed in isolation. And as highlighted in this quote, no single organization or sector can address these challenges alone. So I would like to acknowledge my collaborators and mentors for the support. Thank you very much for your attention.